Okay, geometry, moving on into chapter 8, section 2. This one is on special right triangles. And this section here kind of bridges the gap between the Pythagorean theorem work that we did in section 8.1 and then the trigonometry that we're going to be starting later in section 8.3. So special right triangles takes us through two unique triangles that exist out there, only two, where there's a special relationship between all three sides that we're going to be able to figure out then without a calculator and without using the Pythagorean theorem or any trigonometry for it. And the first of these two special right triangles is called a 45-45-90 right triangle. And what you may have figured out already here or known from the past is that those three numbers, 45, 45, and 90, represent the angle measures, 45 degrees, 45 degrees, and then of course this right angle right here, they give you the angle measures of this particular triangle. Now, because it has a 90-degree angle, this triangle is right. Because the other two angles, 45 and 45 degrees, are congruent, that means that the triangle is isosceles. And a 45-45-90 is the only right isosceles triangle that can ever be drawn. So they look like this diagram over here on the right. You have your right angle, you have two legs meeting to form the right angle, and those two legs are always going to be congruent. So we generically call those lengths x. If one of those lengths is x, the other one has to be exactly the same number because the triangle is isosceles. But the length of the hypotenuse then is x multiplied by the square root of 2. Now, skip this part if you want, but the reason for that, let's say for just a second that we did not know the value of this x root 2, and we simply said that this piece was h for hypotenuse. If we wanted to know how long h was, we could set up the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. One of our legs is x, the other leg is also x, and the hypotenuse here is h. So that's the Pythagorean theorem, but our question now is, can we represent this h in terms of x? So what we're going to do is try to solve this equation we just wrote out for h. The x squared and the x squared are like terms. They both have a coefficient of 1, so when we put them together, we add the coefficient to get 2. And then the variable term, the common factor of x squared, just stays exactly the same. So 2x squared is equal to h squared. And now, to solve for h, we would take the square root of the right side and balance that out by taking the square root of the left side. Well, on the right, the square and the square root simply cancel out, leaving us with h. Now, to take the square root of 2x squared, that entire term there is not a perfect square, but the x squared is. So back to what we did in 8.1 with simplifying radicals, we could make this the square root of x squared multiplied by the square root of 2. Well, the square root of x squared can be simplified to just make an x, and the root 2 just tags along because nothing can be done to simplify that. So right here we see that in a 45-45-90 triangle, the length of your hypotenuse is equal to x, which is the length of one of your legs, multiplied by the square root of 2. So let me get rid of some of those markings that I made right over here, and let's get back to just cleaning this diagram up a little bit. All right, so what we have there in blue is something that you guys should have written down in your notes. And ideally, it would be something that we have committed to memory pretty quickly. That the three side lengths in any 45-45-90 triangle are, and some people prefer to write it out as a list right here, the legs are x, and the hypotenuse is x times the square root of 2. That is a group of three numbers that you should really learn. It's actually a Pythagorean triple. Let's see it in action here. Okay, so in example A, let's see what we were given. We see a right triangle with angle measures of 45 and 45. So we can see right away this is a 45-45-90 right triangle. One of the legs is given to us as 8. We've got to come up with the second leg and we've got to come up with the hypotenuse. The great thing about these problems is, guys, that in certain cases, and this is one of them, there's no work at all to be shown. When we go to figure out the length of x, well, two congruent angles here, 45 and 45, means that their opposite sides have to be congruent as well. If one leg has a length of 8, the other one, x, has to have a length of 8 also. And to go from leg to hypotenuse in a 45, 45, 90, if a leg had a length, which we called x on the last slide, we simply multiply that length by the square root of 2 to get the hypotenuse. So if your legs are both 8, your hypotenuse then is 8 multiplied by the square root of 2. And guys, they won't all be that easy, but this one is. When you're given a leg in a 45, 45, 90 triangle such as this, there's really not a whole lot of work to show. Let's take a look at B. Now again, what you want to do is not assume what kind of triangle this is, but we want to actually spend some time thinking about it. In this triangle, we can see that we've got a right angle here. We don't see 45-degree angles the way we did in example A, but what we do see in B are tick marks on the two legs, here and here, and that tells us that this triangle is isosceles. Well, as we said a few moments ago, the only isosceles right triangle that could possibly ever exist is a 45-45-90. Or, looked at another way, if these two sides are congruent, then we know that their opposite angles have to be congruent as well. The sum of your three angles in any triangle is always 180. Well, if this one is already 90, 180 minus this 90 leaves 90 degrees for these two angles to share. And if they share that 90 evenly, 90 divided by 2, that tells you these angles have to be 45 degrees. Okay, so we were given the 11 root 2 for the length of one of your legs. We've got to come up with the second leg and the hypotenuse. So D is the other leg in this isosceles right triangle, and we know that this leg has to be congruent to this leg. So D is going to be 11 times the square root of 2, and that's the end of that. E is just a little bit trickier now. Let's go back to the last problem. To get the length of our hypotenuse, we took our leg, which was 8, and simply multiplied it by the square root of 2. We're going to do the same thing here. We're going to take our leg of 11 root 2, and to figure out E, we're going to multiply the length of that leg by the square root of 2. It's just that the length of that leg is a little bit more complicated now than it was. 11 root 2 is the length of the leg, which we now multiply by the square root of 2. And this expression can be simplified. The square root of 2 multiplied by the square root of 2 is going to get us 2. Not the square root of 2, but 2 itself. So E is equal to 11 times 2, which means that E has a nice clean length of 22. So there's our answer for E, and there's our answer for D. It looks like we did something different in example B, but it's actually the exact same thing that we did in A. You took your leg and multiplied it by root 2. There was just some simplifying that we needed to do in part B. Moving on to example C, now for the first time things have changed a little bit. We have a triangle with a 45-degree angle here and a 45-degree angle here. No word yet about this angle, but let's do a little deductive reasoning. 45 and 45 adds up to 90. The sum of all three angles is 180, so 180 minus the 90 degrees that got used up already leaves us with 90 for the measure of the third angle. That means that this is a 45, 45, 90 triangle, and we now need to come up with the lengths of the other two sides right there. So we've got to come up with the length of G, and we've got to come up with the length of H. Now, things are different this time because we were given, for the first time, the length of the hypotenuse, and we now need to go backwards in order to figure out the length of a leg. So in the last two examples, to go from leg to hypotenuse, we multiplied by the square root of 2. We've got to reverse that now. So to get G, we're going to take the length of our hypotenuse, which is 17 times the square root of 2, and instead of multiplying by root 2, we're now going to divide by the square root of 2. This actually makes a lot of sense if you think about it. In an example like A, we could tell right away that Y, the hypotenuse, had to be the longest side. So to take a smaller number like 8 and make it bigger, multiplication is the operation that will do that. Same thing in B. But when we get to C, we're now going from hypotenuse back to a leg here. It's got to get smaller, and division is the operation that will make that number smaller. Now this expression we just came up with looks a little bit messy, 17 root 2 divided by root 2, but you really shouldn't ever need to go to your calculator on this. The root 2 is an identical factor that exists in both the numerator and the denominator. They simply cancel each other out completely, and G is just equal to 17. So we've got that here. And now that we know the length of G, let's talk about H. H is the second leg in this isosceles triangle. So if one leg is 17, the other leg has to have the exact same measurement here as well. So that's the length of H, and there's the length of G. Let's move on to example D. Now, like C, here we were given the hypotenuse, and we've got to try to come up with the length of the two legs. It's just that the hypotenuse here didn't contain a square root of 2 the way that it did in the previous example, which looked a little scary, but actually made it easier. This problem's going to be a little bit tougher. Okay, so let's try to find J. J is a leg in a 45, 45, 90 triangle. To go from leg to hypotenuse, we always multiply by the square root of 2. But to go backwards from hypotenuse to leg, just like in the last example, we're going to take our hypotenuse, which is 30, and we're going to divide it by the square root of 2. Okay, now to do this, your modern calculators will do this for you. If you type in 30 divided by the square root of 2, the XS Multiview will do the work for you. But let me show you how we do this by hand. It's a process called rationalizing the denominator. What we're going to do is take this irrational denominator with the square root of 2, and we're actually going to multiply this fraction by that denominator, square root of 2, divided by itself. The exact same number on both the top and the bottom. And as we multiply across, let's see what happens. This 30 gets multiplied by a square root of 2 to just make 30 times the square root of 2. On the bottom, you have root 2 times root 2, which just makes 2. Now, it doesn't look like we've accomplished much, but what we've done is we've gone from an expression right here that had the square root on the bottom of the fraction to an expression right here that has the square root on the top of the fraction. And mathematicians prefer that form because it was much easier to divide an ugly decimal by a whole number rather than a whole number by a decimal. But we're not quite done here, guys. That expression that we just came up with here can be simplified a little bit further. The 30 and the 2 are now unfettered whole numbers right there that can be divided by one another. So we're simply going to take 30 divided by 2 and get 15. And the square root of 2 that was in the numerator just tags along for the ride, and we end up with J equaling 15 times the square root of 2. So that's how you divide a whole number by the square root of 2. To come up with K, we're going to recognize once again that J and K are congruent sides in an isosceles triangle, so they've got to be exactly the same thing. So K also has a length of 15 root 2. All right, guys, those were the 4 examples we were going to do on 45, 45, 90 right triangles. Let's take a look at a 30, 60, 90. And again, the numbers refer to the angle measures, 30 degrees, 60 degrees, and 90 degrees. 30 degrees is kind of the sharper, pointier acute angle. 60 degrees is the slightly larger acute angle, and then of course we have a right angle in the corner here as well. So unlike the 45, 45, 90, we don't have any congruent angles here, so this triangle is not isosceles, it is a scalene right triangle. However, the 45, 45, 90 was the only isosceles right triangle that existed, but a 30, 60, 90 is not the only scalene right triangle. There's an infinite number of those. This is just kind of a neat one here. Okay, so in the blue box, this is the relationship that we want to have written down. All right, the 30-degree angle I have drawn here up at the top. That is the smallest angle, which means that this down here on the bottom has to be the shortest leg. And the short leg in a 30, 60, 90 we generically call X. The long leg then this one right over here, the long leg is going to have a length of x multiplied by the square root of 3. And then the hypotenuse, which we have drawn over here on the right, across from the right angle, is going to have a length of 2x. So this is the pattern of three numbers we have to have memorized here. Your short leg is x, your long leg is x multiplied by the square root of 3, and your hypotenuse is 2x. So you might want to look at it that way. Now, not to bore you too much, but where this whole thing comes from is the idea of, you may have seen this one before, an equilateral triangle with angle measures of 60, 60, and 60. And let's just say for the sake of argument that every side in that equilateral triangle has a length of 2x. Well, what we decide to do here to make a 30, 60, 90 out of this is to go from this vertex up here on the top and to drop an altitude straight down to the base. And an altitude means that it forms a right angle. Now what we've just done is we've taken that base down on the bottom here, which had a length of 2x, just like the other two sides in this equilateral triangle, and we've now cut it in half, so that this piece, from that point to this point, is half of that 2x, which is just plain x. And now you can see where the x and the 2x come from. And if you wanted to find the length of this red altitude, which we could generically call h, well, we could do the Pythagorean theorem again. Leg squared plus leg squared equals hypotenuse squared. So you'd get x squared plus h squared is equal to, now be careful, 2x is the length of the entire hypotenuse, and we'd square that. So we'd get x squared plus h squared is equal to, and the reason the parentheses are important here, you've got to multiply 2x times itself, times 2x. The 2 gets squared and the x gets squared. Without the parentheses, we'd probably just be squaring the x. Okay, the 2 squared is 4, the x squared is x squared, and here's where we are. We would now subtract that x squared from both sides. Remember, that's a 1x squared, guys. And we would get h squared is equal to 4x squared minus 1x squared is 3x squared. We would then solve for h by taking the square root of both sides, and we'd get h equals, the x squared is a perfect square, so the square root of x squared brings us an x out in front, but you can't do anything with the square root of 3, so that's what h is equal to, everybody. X times the square root of 3, which is what we got right here. Okay, so you want to make sure that diagram is in your notes, and we want to make sure that this pattern of numbers, this Pythagorean triple, x, x root 3, 2x, is something that we have memorized. All right, let's do 3 quick examples and get out of Dodge here. All right, let's take a look at A. All right, first of all, what are we dealing with? We see a triangle, not necessarily a right triangle, until we do some figuring. 2 angles are given to us of 30 and 60. That adds up to 90, and 180 minus 90 tells us that we must be dealing with a 90-degree angle for the last angle. So this is what we've got. We were given 11 here for the length of the short leg. I know it's the short leg because A, it looks like a short leg, but B, it's also opposite from the 30-degree angle. So this definitely is the short leg over here on the right-hand side. Okay, so let's go ahead and let's try to find F first. Now F is going to be the long leg in this 30, 60, 90. And the way we find the length of the long leg is to take your short leg, which is 11, and multiply it by the square root of 3. We would simplify this expression if we could, but you can't, guys. That's all she wrote, and that's as good as it's going to get. F is equal to 11 root 3. G is probably actually a little bit easier than that. G is our hypotenuse. And to come up with the length of the hypotenuse, remember on the last slide we said that if the short leg was x, then the hypotenuse was 2x. We simply take x and multiply it by 2. Well, our x was 11. So to come up with the length of the hypotenuse, we take the short leg, 11, and multiply it by 2. This one can be simplified a little bit. 11 times 2 is going to tell us that G has to have a length of 22. Example B is a little bit tougher. So we have a triangle with a 90-degree angle and a 60-degree angle. And really, guys, once you've matched up two of the angles with what we need, we don't have a choice now. The third angle has to be 30 degrees when we use the angle sum theorem. Okay, in this problem, we were given 34, which is the length of the hypotenuse. And we've got to come up with the length of the short leg, W, and the long leg, which is P. Okay, so to do that, everybody, we always start off, this is important, finding the short leg if it wasn't given to us. The long leg can wait, but the short leg is really the key. So to find W, which is our short leg, all right, in the previous problem, to go from short leg to hypotenuse, we multiplied by 2. We now need to go backwards. We now need to go from the hypotenuse back to the short leg, which we're going to do by reversing our steps and dividing by 2. So W is going to be 34 divided by 2, which equals 17. So that is the length of W. And now that we know that W is 17, to go from short leg to long leg, we simply multiply it by the square root of 3. So P, we take our short leg of 17, multiply it by the square root of 3, and nothing can be simplified there. That's our best case scenario answer here for P. All right, so B, we were given the hypotenuse here. We had to go backwards. We had to divide to make it smaller. And last example, and this is the toughest of the three, is example C. Now again, 90-degree angle, 30-degree angle, so we know this last one has to be 60. That means that we were given the length of the long leg, or the middle side out of the three here. We've got to come up with the length of the short leg and the length of the hypotenuse. Now, like I just said on the last problem, the short leg is always the key. We definitely want to find J first, and then eventually we'll use J in order to find M. So, how do we find J? To go from short leg to long leg in the last two problems, we have multiplied by the square root of 3. Well, now we're going backwards. So to go from long leg back to short leg, we're going to have to divide by the square root of 3. So this is going to take a little bit of work. J is going to be 27 divided by the square root of 3. If you have a newer calculator, go ahead and type it in. But if not, here's how you do it. We did this with the square root of 2 before. Now we're going to multiply by the square root of 3 on both the top and the bottom of that fraction. Again, this process is called rationalizing the denominator. So the 27 times the square root of 3 is just going to get us 27 root 3. Down on the bottom, though, root 3 times root 3 is 3. And again, the 27 and the 3 here are numbers that can be divided. 27 divided by 3 is 9. And the root 3 just tags along. So 9 root 3 is the length of J, which is our short leg. To come up with M, which is our hypotenuse, we go from short leg to hypotenuse always by multiplying by 2. So if J, our short leg, is 9 times the square root of 3, we now need to multiply that by 2. And here, it's the 9 and the 2 that can be put together to make 18 times the square root of 3, and that is the length of the hypotenuse, which is M. Okay, everybody, that's a wrap on section 8.2. Let's give that homework a try and see how we do on that. If you guys have any questions, make sure you post them in comments.